Hello everyone, and welcome to another Dolphin Communication Project webinar. We are excited to be talking today about the nearshore habitat use of Atlantic spotted and bottlenose dolphins off Bimini, the Bahamas. If you're listening live, you will find your microphones muted, and that's on purpose. So please submit your questions to the chat. Nicole and Kathleen are monitoring the chat in the waiting room for us. And I am joined this evening, very grateful for her help. Dr. Christine Ribic is here to go through this with me. And do you see a big white box here?
Yes.
Okay, I don't know why that is. So we got better than before, but that's going to be, oh, okay. Stay away, big white box. You know what? I'm going to do one quick thing. Okay, so apologies for that. This is a little screenshot of our publication. Our paper was published in the Caribbean Journal of Science in August 2022. Chris and I worked on it with Dr. Levengood, Dr. Dudzinski, and our GIS guru, AJ. If you need a copy of the publication, you can let us know and we will get that to you. Kathleen and I also presented this work at the August 2022 Biennial Conference on the Biology of Marine Mammals that was held in West Palm Beach, Florida. But you had to be registered for the conference to watch it, and we only had 9 minutes to talk about it. So we wanted to use this talk to give us a chance to really go through the nitty-gritty of the paper and share it with the general public. So a little background first. Sympatric really just means that two or more species share the same space. And that might sound very simple, but it is really one of the most foundational questions and concepts in ecology. There simply is only so much space on Earth. And so different species have to share space. This might be beneficial at times, but other times sympatric species might end up doing different things at different times or in slightly different spaces. In other words, they might segregate in order to reduce overlap. And a reduction in overlap might in turn reduce competition. Reducing overlap and competition is particularly important if injury is possible and when two individuals or two groups were to interact. And despite what you might imagine or see on nature television, most individuals don't actually want to take the risk of fighting. So asking questions about how species overlap or segregate is difficult in the marine environment. We simply can't watch the species in 360 degrees at all times. So big questions remain, like how can two sympatric or overlapping species both be successful despite needing to compete with each other? If you find dolphin sympatry very interesting, you might check out Bearsy's 2005 paper. It provides a review of some well-studied sympatric dolphin species and discusses the nature of habitat and resource partitioning. You can find the publication online, and if you have any trouble, you can just give us a shout and we'll help you out. So if this discussion of spotted and bottlenose dolphins using the Bimini coastline sounds familiar to you, perhaps that's because you read our 2015 paper. Kathleen and I worked on that with our colleague, Dr. Yeda, and this paper gave a baseline of dolphin sightings around, sorry about that, immediately off the coast of Bimini prior to the construction of a big cruise ship pier. And we're going to talk about that pier in a little bit down the line. So this time around, we asked, how do the two species, not just did they show up along the coastline, but how did they spatially segregate? How did they separate themselves in space along the nearshore coast of Bimini, along the shoreline there. So did they segregate geographically, north to south along the coastline? Did they segregate by water depth? So inshore, right, is more shallow. And then as you go offshore to the west, it gets a bit deeper. And then we wanted to ask questions like, how do the two species behave when they are in this nearshore shoreline area? So if you have listened to other DCP webinars or read our papers or even joined us in the field, you might already be familiar with where Bimini is. So it is actually two islands inside this orange circle. There's North Bimini and there's South Bimini. It's very little. And it is resting kind of on the northwest corner of this shallow area. This is the Great Bahama Bank. And this darker color here, more solid color, this is the deep Gulf Stream. The Gulf Stream waters are running north. It's a pretty strong current. And this is our study area, or was our study area. So wanted to show everybody where Bimini is relative to South Florida. Here's Miami. And where it is relative to the rest of the Bahamas. And this isn't even all of the Bahamas. The Bahamas continues beyond what's shown in this map. And of course, our study species. Everybody came to hear about dolphins. We have Stenella frontalis, or the Atlantic spotted dolphin, a common name that generally makes sense, found in the Atlantic Ocean. They have spots, and Tursiops truncatus, or the bottlenose dolphins. So today, while Chris and I are talking, we might call them spotteds, we might call them Stenella, we might call them bottlenose, we might call them Tursiops, but these are the two species that we're referring to. The spotteds tend to be a little bit smaller, and off the coast of Bimini, we actually know more about them than we do about the larger bottlenose. So methods, what did we do in this study? So here is North Bimini, and here is South Bimini. And to collect our data, we headed out on a locally owned and operated tour boat. We left Allenstown Harbor. There's a little cut here you can get between the islands. And this area in purple that you see here is actually just a subset of DCP's bigger Bimini study area. But as we cruised along the coast, on our way out, we're looking for dolphins, we're looking for dolphins, we're looking for dolphins, we're continuing to the rest of our study area. And in order to get home, we have to come back through this exact same area. So each boat trip, unless we found dolphins and spent the whole day there, each boat trip has two passes through this nearshore area. This arrow is roughly where the big cruise ship construction was in 2014. So as you can see, kind of right smack in the path, pretty much right smack in this shoreline zone. So we removed 2014 data from this study. We did not specifically study the cruise ship construction, but you can imagine that's going to have pile driving, that's going to have dredging, it's going to be noisy and silty, more boat traffic coming in and out. We just excluded that year. So our questions are going to be related to before 2014 and after 2014. We also removed data from October to March. Those were really more opportunistic, like if the boat was going out and the weather was good and we could go see what the dolphins were doing in the winter. Most of our data were collected April to September, so those are the data we included. And then sometimes we see mixed species groups where the spotteds and the bottlenose are together in one group interacting. And then sometimes we have an unconfirmed species. That doesn't mean that it's a brand new species that we've just discovered. It means the sighting was too quick or the dolphins were too far from the boat for us to really be confident in which species we were seeing in that moment. So we also removed mixed species groups and unconfirmed species. And that allowed us to really dive into, if you will, the single species. What are the spotted dolphins doing, and what are the bottlenose dolphins doing? Then when we would see dolphins, we would mark the time of day, what it is, and use our handheld GPS. Here you can see one of our past interns. And we'd mark the latitude and longitude so that we knew where that sighting began. If the boat had a depth finder, we also noted the water depth, and we're going to get into what happened when we didn't have a depth finder on the boat. We recorded those data. Then we would safely proceed and continue our observation of the dolphins. It's not listed here, but of course we would write down which species we were looking at, the spotteds or the bottlenose, and then also the group size, the general behavior, and the group composition, particularly for the spotteds. Now, group size, behavior, group composition, I'm going to fill you in on the specifics of those, what they mean, how we define them, when we get into the results, that way you hear them together. And then with that, I am going to pass the methods over to wonderful Chris.
Well, thank you, Cal. So now I'm going to be talking about how we actually looked at the spatial distribution of the two dolphins. And as you can see, we basically have a rectangle here. And so when you look at space, you generally look both in all the cardinal directions. So north to south and east to west. In our case, north to south is basically along the inshore. And because we are interested in seeing if there was any effect of the pier, we first defined the central zone. That, as you know, that encompassed the pier and then also the activities such as the all the pile driving, and then also the post-construction use of that pier area by the cruise ships. So that made up about 15% of the study area. And then, of course, the other two pieces are the north zone, north of that, about 53%, and then the south zone, which is 32%. And these zones of equal area, of unequal area, are okay because we're going to be able to take that into account when we analyze the sighting. So we basically took all the lat longs for the different sightings and just binned them. Did they fall in the north zone, central zone, or south zone? Next slide. Kel, next slide. Okay. So what we're going to do now for the east to west, that's the inshore to the offshore, is to look to see if there was any differences in that gradient. And in order to do that, we could use, for example, distance from land, but distance from land is just a proxy for actually water depth when it gets deeper. So what we did, the first thing that we did is we looked at the U.S. coastal relief model, which is a model for the world, trying to look at bottom topography or the bathymetry. But it's not really reliable in all coastal areas. And in fact, in the Bimini area, it just sort of basically, it's just sort of this blue background. It's just sort of like, there's no topography, bathymetry. We know that's not true. And so what we ended up doing is building our own model. So what we did is we took a page out of what a lot of marine mammal scientists do, and we used the animals themselves to give us the depth information. As Kel noted, there were, when there was a depth finder on the boat, they had water depth. So we had lat long and water depth. So we had all those sightings. We also had sightings outside of our study area, which is very important because that allows us to get a really good relief map and then just sort of take a cookie cutter to just specifically look at our sites. In other words, we don't have what's known as edge effects, where you just sort of drop off the map, right? This allows us to have a much larger area that gives us a smooth transition. Besides the animal sightings themselves, we also had depth readings from some local diving sources. And also Kel took 652 observations of dolphins that didn't have depth readings and put them into the Navionics nautical sonar app and actually got 652 additional depths for us. So we took all those locations and depths into a GIS. We use the smoothing algorithm so that for any observation where we didn't have depth, we could now interpolate. We could also then, in next slide, is actually then define different areas from inshore to offshore that made sense biologically. So we ended up using 4 depth categories. So all the observations were then categorized as falling into one of these 4. And basically it's by depth, but what they represent are different bottom types. So less than 5, which is the light blue, is basically the nearshore sandy beach area. Then the medium blue, which is actually 5 to 12 meters in depth, is actually represents the nearshore reef system, which has eelgrass beds and sandy bottoms. Then as we go a little further offshore, sort of that darker blue, that's 12 to 20 meters. We're calling that the shallow deep transition zone. It also has sand and seagrass beds, but there's more of a slope going out to the greater than 20-meter deep water, which is the really dark blue. Now, as you can tell, the study area basically tried to parallel the deep water. So we do have a little bit of deep water in there, but not a lot, and that's okay. The other thing to notice is that the geographic zones have different proportions of these water depth categories. So for example, in the North Zone, you have about 60% is in the nearshore reef system area. When you go down into center and then the Southern, that actually declines. So the proportions are different, and that's going to affect how we analyze things, but we are going to take that also into consideration in our approach. Slide. So analysis, I'm not going to go into the nitty gritty. It is actually in the paper, but our general approach was to use log linear models. And we're going to be looking to ask questions about how the sightings differ from geographic zone or depth category, and then also how they differ among the species. So I just want to make at the outset say every analysis we do first a comparison with pre and post 2014 data. We want to know if there's any differences between those 2 time periods, because if they are, that tells us something's changed, which is the idea of maybe the pier had some kind of difference to this metric we're looking at. But once we did that, if there was no difference, we would then combine the data, because there's no difference. Why are we keeping them apart? And so what we did is for geographic distribution, this is where we take the differences between the zones into account and the water depths into account by using what we call use and availability comparisons. We're specifically asking, do the sightings, which are the use, follow the proportional pattern of areas of the geographic zones or the water depth categories? That's your availability. If they're basically the same as availability, the dolphins aren't doing anything other than randomly choosing where they want to be. Now, for species use of the coastal area, we can look at the between species with their behavioral activity and group size comparisons. But with the spotted dolphin, they're the only ones that we had group composition. So we just looked at within the dolphin, spotted dolphin, for group composition differences. And we did check for, excuse me, geographic zone and water depth category variation for these behaviors. Okay.
So just a quick, when scientists go do a study like this, are they just out there for a week and they see a couple of dolphins and they write up a paper? We wanted people to see how much effort goes into a long-term study like this. So we included data from 2003 to 2018, but remember we took out 2014, not because we're trying to hide anything, but because that's the year of potential impact and we don't have data specifically on the pier, so we can't include it. In total, we were out there more than 800 days. Pre-2014, that meant 129 spotted dolphin sightings and 142 bottlenose sightings. Post-2014, That was 124 spotted sightings and 62 bottlenose sightings.
So we actually have quite a bit of data. So that was able to actually look at our questions and get some good analyses. So just overall, when we compared pre and post 2014 distributions for the geographic zones, they were the same. There was no statistical difference. And so we're going to basically combine those data and ask the question, how did the spotted dolphin use the geographic zones? And this, you're going to see this sort of setup for the next couple of slides, where there's text on the slide, and then there's going to be a graph. And the graph is basically why we can say what we're saying on the slide. So the first thing to notice is that the study area proportions are presented in purple. That's the availability. And again, we're wanting to know if, and then the green here is the spotted, and it's their use. And so if they were using it the same as availability, those two bars in the north, central, and south would be the same, very similar to one another, but they're not. In fact, in the north, basically the spotters are seen more. So they overuse the north zone and they underuse the south zone. And they basically use the central zone in proportion to availability. So they just sort of were there, but they were definitely overusing the north and underusing the south. So what about the bottlenose dolphin? So they're in orange. That's where their bars are. And they also did not follow availability, but their pattern was different, actually the opposite of what happened with the spotted. The bottlenose underused the north zone and overused the south zone. So right off the bat, we know that these dolphins are spatially using the coastal area differently. So let's move on to water depth. So now that's like a smaller area, but are there any differences? Now, the only place that we found a difference in pre and post 2014 distributions was in the north for spotted. That's why there are two green bars. The light green is pre-2014 and the darker green bar is post-2014. So in the north, the pink represents the proportion of the water depth categories that are available to the dolphins, to the spotted dolphins. They did not use the water depth categories in proportion to availability. They actually weren't really ever seen very close to shore. What they did is they overused the nearshore reef system area. And then it was both in pre-2014 and post-2014. And then they also in post-2014 appeared to sort of like increase their distribution. They started to overuse the shallow to deep transition area. So that was really, in both years, they used that nearshore reef system. And then in 2014, they also started to overuse the shallow to deep transition area. In the center zone, again, the pink shows the availability of the water depths in that center zone. And in this case, the spot is overused the shallow to deep transition area in green. And in the south, again, pink is representing the availability. Again, the dolphins are not using it in proportion to availability, but in the south, they overuse the nearshore reef system area. So they're not really consistent in how they're using the different water depths. They're sort of bouncing around. How about Tursiops? So in this case, it didn't really matter whether you were in the north, the center zone, or the south zone. The bottlenose always overused the nearshore reef system area. So they were very consistent about what water depth they were using. And so, of course, the question is, why might we see this variability in the spotted, but not in the bottlenose? And we're going to try and look at that by looking at what are their behaviors.
So I promised we would tell you what behaviors, how we categorize this. We just use three very broad categories that would be applicable to both species. Feeding, So for the bottlenose, that usually meant they were crater feeding. That's what this dolphin is doing here in the picture. You can guess why it was given that name. Looks a bit like craters on the moon. They cruise over the sand, they look for buried prey items, and they gobble them up. The spotteds, on the other hand, don't really use this feeding technique. We think that they tend to feed in the deeper water offshore at night, farther from shore. Though we know they are capable of crater feeding, we rarely see them crater feeding. The second category we used was travel. So it's the whole group generally going in the same direction without different individuals veering off and doing their own thing. Then they're traveling. And then other. This is kind of our catch-all social grouping. Are they mating? Are they peck rubbing? Are they playing with objects? Are they riding the bow? They're doing all of the other things dolphins do in the ocean when they're not feeding or traveling. We didn't generally see rest as we would want to define it in this study area. So that's why that's not included at all. Feeding, travel, and other.
So these data are a subset of all the observations because they didn't have behaviors on everything. So that's just to give you a clue that now we're starting to sort of look at these data, but we're able to have, we don't have as much as we had with water depth and the geographic zones. But so we had 219 observations for the spotted and 147 for bottlenose. There were no behavioral differences by pre and post 2014, geographic zone, or water depth for either of the species. So all we need to do is look at this graph. And what we can see is that the spotted are now in green and the bottlenose are in orange. And what we see is that bottlenose feed a whole lot more in terms of behavior seen than the spotted. And the spotted do all this other behavior that Kel talked about. Traveling, they did it about the same. So the big difference is that they were really, the bottlenose were feeding and the spotted were not. And they were doing all that other stuff. And so we wanted to keep looking at some of these other characteristics to see maybe that's going to support what we're seeing or give us some more insight into this. So group size was collected. Oh, go ahead.
Sorry, Chris, go ahead.
Yeah. No, I was going to say we're going to look at group size, and I was going to let Cal tell you what those group sizes are.
Thanks. So we wanted, in this case, to be consistent with that baseline paper, that 2015 paper, for comparison's sake. So we looked at small groups, was just 1 to 5 dolphins in the group. Large groups, 6 to 19 dolphins in the group, and extra large groups are 20 or more dolphins in the group. So here now Chris will chat to us about what the different species did in terms of group sizes in this study area.
Right. So again, there were no differences in group size by time period. So we didn't have to worry about that. Green again is your spotted dolphin and the orange is bottlenose. And when you compare these two distributions, they are not the same. In fact, you have a lot more small groups of bottlenose, and you have more of these extra large groups of spotted. In fact, they saw no bottlenose in these extra large groups. So that's sort of the general difference between the two species in terms of they are different in group size. Okay, next slide. But they're also within the species, they're doing something different in terms of the group sizes using the different geographic zones. So this is the spotted dolphin. This time, the bars, blue stands for the north zone, and the orange bar is the central and south together. And they were combined because the patterns of group size in the central and south were not different from one another. Basically, the difference was between the north zone and the central and south combined. And so what you see is that in terms of group size, you have more large groups in the north, that's in the center there, and you have more small groups of spotteds in the central and south. So something's going on that way in terms of they're not, these group sizes, they're not using the geographic zones the same way. So how about the bottlenose? So in this case, for bottlenose, we didn't combine the central and the south because the patterns are actually different. In this case, north is going to be blue, and the orange now is central, and then you have the yellow, which is the south. And what we have here is that in the north zone, you have a lot, bottlenose are more apt to be small groups. And in the central zone is where, I can't see the slide, is where they have the large groups. Is that what? Oh no, yeah, large, because they were only seen as small or large. So that's all we have. So they are, again, not doing the same thing in terms of group size in the geographic zones. Okay. What about water depth? So for water depth, group size did not differ by water depth in the spotteds, but it did differ for bottlenose. So basically, bottlenose small groups were seen more often in that near shore sandy area, less than 5 meters. And the larger group, the large groups, were seen in that shallow to deep transition zone. So again, if you think about it, when we were talking about crater feeding and things, basically they're small groups of dolphins. So it's not the large groups of bottlenose are not the ones doing the crater feeding. They're basically the small groups. And so a lot of the things that we're seeing in terms of the small group size and the behavior are sort of tying together. Okay. So in terms of maybe these sizes of groups have say something about the group composition. Well, we didn't have enough data to actually tease that out, but we could look at group composition for the spotteds. And so I'm going to let Kel talk about the different group compositions that are abbreviated here on the slide for you.
So you could look at a social species, that comes together as a group, and you can parse out all types of different groups that you might describe. We took these 4 group types. We had enough data to ask some questions about them. The sample size was big enough. So right here, you have adult females who are with juveniles. Here you have just groups of juveniles. They're on their own. Here you have mother-calf pairs, though that might be one mother-calf pair or multiple mother-calf pairs. And then mixed. And the mixed means that it's males and females and more than one age class. Now, a mother-calf pair, where the calf is a male, is a mother-calf pair, not a mixed group, even though it's 2 different age classes and it's males and females, a male and a female, excuse me. So the mixed males and females, multiple age classes. And so these are the 4 that we had large enough sample sizes to ask some questions about them.
Okay, great. So again, the north group composition proportions are in blue, and the orange are for the central and south, because again, the central and south group compositions were basically the same. And so what we can see just by looking at the arrows is that the females and juvenile group, as well as the mothers and calves, were preferentially using the central and south shore. And it was the mixed groups that were basically seen up in the north. And there was no evidence that group composition varied by depth categories. So what we're seeing then is that we've got some differences, not only in how the 2 species use the inshore and water depth, but we also within the species have variation and differentiation in how they spatially use the study area. And so what I'm going to let Kel do is take over and do the whole big summary of what we're doing in this study.
What did we just throw at you all? So first off, neither species showed a meaningful difference in space use between the pre and the post, right? So that allowed us to pool the years, gives us more data in order to see patterns or lack thereof. Looking at all of the years, the spotteds used the north zone more, whereas the bottlenose used the south zone. So if you remember from the beginning of the talk, that was one like jumped right out at us that they're doing the opposite thing. For water depth, the spotteds used the 5 to 12 and the 12 to 20 more, whereas the bottlenose consistently used the 5 to 12, regardless of the geographic zone. The different uses of these depths and these zones may have to do with what the dolphins are doing when they're in those areas, right? So spotteds are in larger groups in the north, and across the board, they're doing more social behaviors, that giant catch-all other group, whereas the bottlenose are in smaller groups and they're feeding more, specifically crater feeding, but they're feeding more. We found some evidence that for both species, group size could vary a bit by geographic zone. And for bottlenose, that group size could also vary by water depth. When it came time to do the questions about group composition, we could only ask those questions about the spotted because we just don't have enough male-female data on the bottlenose. So we really couldn't kind of suss out different group types for the bottlenose. So looking at the spotteds, generally, they're more mixed groups, right? Males and females, multiple age classes up in the north, and more mother calf, juveniles, adult females in the central and the south. Is that a social adaptation to giving those maybe more vulnerable younger individuals in the group a little bit of space from the big giant groups? Maybe. But it was certainly interesting to really look at all of these ways that we could address and ask questions about not just, yeah, we see dolphins off the Bimini coastline, which dolphins, when, how. We were able to ask those questions. So some takeaways. Within this nearshore area, the shoreline area, yes, spotted and bottlenose dolphins did separate spatially by using different geographic areas and different water depth zones. We think that this segregation, this separation, this partitioning may be resource driven. So we observe the bottlenose dolphins crater feeding, that digging in the sand for their snacks, but we don't see the spotteds doing this. The spotteds likely focus their feeding further offshore, possibly even at night, deeper water. So if the two species have found a way to reduce the competition over food by having different feeding techniques that are successful in different areas, maybe it reduces aggressive interactions, because aggressive interactions can be dangerous. These are very big animals with strong tails and sharp teeth. And as our research group defines aggression, we actually don't see a whole lot of it, either within species groups or between the species. And between species, we instead see more socio-sexual interactions. And so maybe they've just figured out how to not need to compete all the time so they don't have to get into aggressive interactions that can be risky. So keep in mind that we collected these data in the context of other stuff that was going on. So the construction of the pier, the new use of that central zone with ferries and cruise ships coming in and out, regular boat traffic from tourism industry, fishing was always going on. And then also in 2013, there was an influx of spotted dolphins from the northern Bahamas. If you want to learn more about it, we have a deep dive on it. We have papers on it. We have a Dolphin Pod episode on it. You can learn lots about it. The short and the long-term impacts of these out of town spotteds moving in are still being studied. But it is possible that this event is what kind of gave those shifts in the spotted dolphins space use. We, of course, have to acknowledge the manuscript co-authors. Chris and I could not have done this without Alexis, AJ, and Kathleen, so big thank you to them. And all of the data in this study were collected under annual permits issued to DCP from the Bahamas Department of Marine Resources. And science takes money, especially science that uses boats. So we have our funders who donated actual dollars or boat time. And then we thank the DCP supporters, interns, volunteers, and the whole Bimini community that really kind of welcomed us here to collect these data and study these animals. Before we get to questions, I'm just going to do our usual webinar wrap up. If you haven't watched all of our webinars and you want more, you can find all the recordings on our website. Just look under the Knowledge Hub. And then also on YouTube, look for Dolphin Communication Project. And this was a deep dive, so you can tell it was a little bit longer. We've been going for about 45 minutes. Advanced, right? We're not shying away from the nitty gritty. We also have dolphin lessons that are shorter. They're geared more towards elementary students, but we welcome everyone. And then if you've gone through all of our webinars and you still need more, be sure to check out our podcast, The Dolphin Pod, either directly from our website or wherever you get your podcasts. And if you're watching this live or in late 2022, what year is it? Then you may not know that we have a brand new online shop. So you can head there for all your dolphin themed swag, bracelets, t-shirts, rash guards, hoo rags, bandana things. And we have snazzy, sophisticated performance polos now. So go check that out if you want to look good and support DCP while you're doing it. And thank you. As always, we are thrilled to be able to offer free educational programming, whether it's our webinars, podcast, kids science activities, but we couldn't do it without our supporters. So if you'd like to support, you can become a member, you can shop, you can join us in the field, you can select us as your Amazon Smile charity. If you need good reef safe sunscreen, conditioner, things like that, check out Stream to See and be sure to pop in the promo code and they'll donate to us and it doesn't cost you anything extra. And just stay in touch. You can see all of our contact info there in social media and we love hearing from you. And now we can see if there are any questions.
Thank you, Kel and Chris, for that very interesting discussion. That sounds like a ton of work. We do have a few questions. First question is, methodologically, it makes sense why you left out 2014, given what was happening. But is there any concern about the fact that there were 11 years worth of data before and only 4 afterwards?
No, because we can use a statistical model that controls for that. And so we're really comparing patterns and it's proportional patterns. So what we're actually using, and so the details are in the paper, but basically the answer is no, the analysis that we chose doesn't require something like equal years or anything like that, because we're actually comparing it to distributions against each other. And that's not required for that kind of test.
Awesome, thank you.
Mm-hmm.
Another question was about the area itself. So besides obviously depth and latitude, is there much difference in terms of like substrate and what is available to the dolphins in the different zones that you looked at?
So I'll snag that one. The shoreline, that kind of under 5 meters, is pretty much just sand. A little bit of rocks here and there, but it's white sandy bottom. So are the next 2 deep zones. Bimini is surrounded by a lot of sand, but the nearshore reef and the transitional zone also have scattered reef lines that run roughly parallel to shore. So you'll have white sand, white sand, white sand, patch of turtle grass, white sand, patch of turtle grass. Ooh, a lovely little reef. So even though we were referencing the reef systems as kind of a delineation and what can happen in that zone, we actually didn't see the dolphins on the reefs. I'm not that big a scuba diver, sorry scuba divers out there, but even in talking to the dive shop here, the local dive shop, tourists who are visiting, and we meet up and I hear about their dive, it's very unusual to see a dolphin actually on the reef. But those two, the middle two depth zones, are kind of scattered with reef and turtle grass. If that answered the question.
It did, yes, thank you. Hold on, let me just read through the question. You addressed that question. And then did any behaviors, or did you find any broadly behavioral differences between the like mother calf, mother juvenile, or adult female juvenile and mixed groups?
Right. The problem there is that's where we ran out of the data. So because we're looking at a subset of behavioral data and a subset of data that's different for group sizes, they didn't overlap enough. So that's the intriguing thing. It'd be really nice to know if we could see that difference, but just because of what we had to work with, we couldn't answer that question.
Okay, that makes sense. Kathleen, did you have any additional questions that I missed?
No, just a sort of a comment. It's really interesting looking at the groups and the species and looking at the different types of groups in the different areas. And it would be fun to look at, and I'm not sure that we have that from the bulk of the data in terms of the numbers of samples per individual identified animals. But I think it would be really neat to see the IDs and where they spend their time. And the individual IDs of dolphins. Do they spend more time in the central or in the the northern or in the mixed? And I think that would be really cool to look at. But that's an even deeper dive than this particular one right now.
Well, it sounds like something I might add to a running list of future questions.
Exactly. And we all know that getting people connected to individual dolphins does help inspire people to want to protect them.
Mm-hmm.
Yes. Well, those are all the questions that I have. Thank you very much to both of you, to all three of you, for all the work you did.
And thank you.
Thanks,
Thank
everybody.
you for joining, and a huge thanks to you, Chris, for doing this with us. I really appreciated working on it with you, and knowing that, just like the paper, describing the statistics and the results was in good hands, better hands than mine. So thank you very much.
You're welcome. All right.
Thank
Awesome.
you.
Good night, everyone. Thank you.
Bye.
Thank
Good
you.
night.